Hello. So here we are going to discuss what are antiparticles. So in 1932, an American physicist, Carl D. Anderson, was experimenting on cosmic rays that come from space. So his instrument called the cloud chamber consists consists of a supercooled vapor inside, and he used it to measure or rather to trace the trajectory of the particles that come from the cosmic rays that would hit inside the cloud chamber. So the cloud chamber, here's a view inside. So inside the cloud chamber, you have a a lead plate, and so in his experiment, he observed that there's a particle initially coming straight towards the lead plate, and then after it hit the lead plate, it penetrated the lead plate so that it lost its kinetic energy, its velocity, and after it hit the lead plate, it came spiraling into this direction. So inside the cloud chamber, he put it he put it an magnetic field. So the magnetic field is pointing towards the page in this as I record this video. So if this particle were to be deflected towards the left with the presence of a magnetic field, Lorentz force tells us that uh, there is a charge. There's a charge that is present in this particle, and moreover, if this particle were to move towards the left, we know that this charge is positive. If you do the right hand rule with V in this direction and B directed towards the page, uh, the force, the magnetic force, the Lorentz force will be towards the left. So this particle moved towards the left. And by analysis, Anderson computed that this particle has the mass of an electron, and but its charge is positive. So of course we know that the charge of an electron cannot be positive because it won't be an electron. So this must be a new particle, and this discovery uh, was the first to prove the existence of what we now call as antiparticles. So he called this new particle the positron. So the positron is an antiparticle of an electron, in the sense that it has the same properties of an electron, except that its charge is positive. So later experiments in 1955 shown that an antiparticle for proton also exists. So there's an antiproton, and there's also an anti-neutron. So by notation, we put a line above the particles so that we know that it is an antiparticle. So in theory, all particles have their antiparticles. So for example, neutrinos have antineutrinos, and so on. except, so this statement has another line to it, except photons and pi naught or neutral pions. So these particles are their own antiparticle. So antiparticles can be artificially produced in nuclear reactions, and they are very short-lived. So when a particle and antiparticle come into contact with each other, annihilation will happen. So annihilation will release tremendous amounts of energy in the form of gamma rays, and it might create also other particles.